now we're going to take the same aggregate production planning model and make a few changes in some extension. So it's the same model like before. Okay. Now suppose if we allow back ordering. Okay. Here when we set the inventory after production to be greater than or equal to forecasted demand, we pretty much guaranteed that there will not be any back orders at all. Suppose if we allow back ordering, okay, then what will happen? Okay, so let's make changes to this existing model. So I'm going to insert a row here, and enter the cost, say shortage cost per pair of shoes per month. And this is given in your textbook to be $20. Okay. So now given that, okay, now the rest, all of this would be the same. Okay, now inventory after production is not going to, no, you're not going to require that to be greater than or equal to ending inventory, because you're allowing the ending inventory to be negative. So we have to remove that. Okay, and we have to now include, besides holding cost, so you have to include a row for shortage cost here. So you go to insert rows and we'll put shortage cost there. Okay. Now the holding cost will be applicable only if the ending inventory is greater than 0. So otherwise it will not be there. So we have to change this formula from that to, first we have to see whether B38 is greater than 0. Okay. Only if it is greater than 0, you will have B38 times the holding cost. Okay. Otherwise, the holding cost will be 0. Okay. I copy that. Okay. Now we have to name this cell. Then shortage cost will be only if the ending inventory is less than 0, there is shortage. Okay. If that is so, then the shortage amount is minus of that. So it's a negative number. So you have to convert that to a positive number. So minus B38, that will give us in positive value how many units we are short times shortage cost, that cost. Otherwise 0. Okay. Now you copy that everywhere. So that's your total, and make sure that this total now includes the shortage cost. So this should be summed up to F47. So that's your total. That's the objective that we have to minimize. So now we go to solver and make sure that you remove inventory after production is greater than or equal to forecasted demand. That's no longer the case because we are allowing shortages to happen. Okay. There is one more thing that we have to do, and that is, since we use the if function in calculating the shortage cost and the holding cost, the linear model is no longer valid. So you have to change that to GRG nonlinear. Okay, now solver has found a solution. Okay, let's first clear the previous solution. Okay, and then run solver again. Now, one problem with not being able to use linear model and having to rely on GRG nonlinear is that we cannot be sure that we got the best possible answer. Because depending upon the initial values that we have for the changing cells, we may or may not reach the best possible solution. So we have to try one or two different alternative starting values and then see whether that makes a difference. So let's it can be quite arbitrary. There is no rhyme or reason why we have to choose one value over another for the starting point. Remember, this is just the initial set of values. And we'll also go back into options and then see. Okay, so integer optimality, we'll put that to 0. And this is unchecked because we have two integer constraints. Okay, so now solve again. Okay, so you get a different solution now, 691 440. Your textbook has 690 180. So maybe some more trial and error is needed to reach that value for the objective function. But we won't try to replicate what's in your textbook because I'm going to show you a trick by which we don't have to use the if function for holding cost and storage cost. It is because of that if function we had to change from simplex LP into GRG function, GRG nonlinear. And for that, what we're going to do is we're going to insert, after forecasted demand, let's go ahead and insert 3 more rows. Okay, actually we need 5 rows. So I'm going to insert 2 more rows. Okay. So now what we're going to do is, well, let's clear this. Okay. Now here is the ending inventory. Now what we will do is we will set up, this is a trick that we're going to play. Okay. We'll set up leftover and shortage. Okay. And we will let Excel solver figure out what those values will be. So they'll all be positive now. Then you have leftover minus shortage will be that minus that. So leftover minus shortage. Now that must be equal to the ending inventory that we have, that we calculate from the model. So the model calculates what the ending inventories will be. And now if you set a changing cell and force the difference between the leftover and shortage to be equal to that ending inventory, then Excel solver will have to separate out. So if this is positive, it will put the leftover at 1260 and that will be equal. If it is minus, if there is a shortage, then the shortage will be placed here and that will be minus 700 equal to minus 700. So the negative and the positive will be converted into both being positive with this changing cell in Excel solver. So once you have done that, then your holding cost need not be if. So all you have to do is to use the leftover times the holding cost per shoe, and then shortage would be the shortage times the shortage cost. Okay, now you copy those two. So now you've gotten rid of the if function. Okay, so before we go back to solver, let's give some names for these three. Okay, then we go into solver. Now we have two more range for changing cells. Okay, and then we have to add the constraint that is equal to that ending inventory. So we have leftover minus shortage equal to the ending inventory. Okay, and then we have added leftover and shortage there. So we did not have a range name for ending inventory, so let's give a range name for ending inventory. Okay, and now we can change that to simplex LP. So then that will give us the best solution, which is 690,180. So here we have the leftover and shortages. So this little trick avoids the if functions here, and because of that we can choose simplex LP, which is a much more powerful solution methodology, and it will give you the optimum solution. You're guaranteed to get the optimum solution, unlike the GRG nonlinear. GRG nonlinear, there is no way for us to know that that we have developed, we have found the best possible solution.